Hi everyone! Now I'm going to teach you about understanding ARIMA model, a powerful time series forecasting technique. Autoregressive integrated moving average is a popular statistical model used for time series forecasting. It combines autoregressive or AR and moving average or MA components to capture trends and patterns in data. Make it a versatile tool for analyzing and predicting various types of time-dependent data. In this slide, there are key components of ARIMA. Number one is autoregressive or AR. The autoregressive component models the dependency between the current value and the past values of the time series. The component number two, integrated, I. The integrated component deals with the non-stationarity of the time series by differencing the data to make it stationary. The last component is that moving average or MA. The moving average component models the dependency between the current value and the past errors or residuals of the time series. In this slide, I want to teach you about stationarity and differencing. Number one, stationarity. Stationarity is a key assumption for ARIMA models where the statistical properties of the time series in bracket mean, variance, and autocorrelation remain constant over time. Number two, differencing. Differencing is a technique used to transform a non-stationary time series into a stationary one by calculating the difference between consecutive observations. Number three, determining differencing order. The order of differencing is determined by analyzing the autocorrelation or partial autocorrelation function of the time series. Okay, in this slide, we want to check or we want to identify the ARIMA parameters. Number one, identification. Determine the appropriate values for P, D, and Q parameters of the ARIMA models. Number two, analyze. Examine the autocorrelation and partial autocorrelation function to identify the suitable value for the model. Number two, adjust. Iteratively adjust the parameters until the best model fit is achieved. Last one, optimize. Use information criteria such as AIC or BIC to select the optimal ARIMA model configurations. Okay, in this slide, I'm going to teach about estimating the ARIMA model. Number one, fit model. Estimate the parameters of ARIMA model using statistical techniques such as a maximum likelihood estimation. Number two, evaluate fit. Assess the goodness fit of the model by examining various diagnosis measures, including residual analysis and statistical significance of the parameters. Number three, refine model. If the initial model does not adequately fit the data, adjust the ARIMA parameters and repeat the estimation process until a satisfactory model is obtained. Okay, what should we do? Here, we need to diagnostic checking for ARIMA model. The first one is residual analysis. Examine the residual of the fitted model to ensure they are white noise, in bracket uncorrelated, and have constant variance. Model diagnostic. Perform statistical tests such as L-Jung-Bok test to check the overall goodness of fit of the ARIMA model. Stability check. Verify that the ARIMA model is stationary and invertible to ensure the reliable forecast. Iterative refinements. If the diagnosis checks reveal issues, revisit the model identification and estimation steps to improve the ARIMA model. Okay, this is the last step I think, forecasting with ARIMA model. Number one, input data. Provide the ARIMA model with the historical time series data. Number two, generate forecast. Use the estimate ARIMA parameters to generate future prediction. Number three, evaluate forecast. Assess the accuracy of the forecast by comparing them to actual observation. Okay, in the last slide, I will teach you about what is the application of ARIMA model. Number one, we can check by economic forecasting. In economic sectors, ARIMA models are widely used to predict economic indicators such as GDP, inflation, and unemployment rates. Number two, sales forecasting. ARIMA can be applied to forecast sales data, helping business plan production, inventory, and marketing strategies. Number three, stock price prediction. ARIMA model can be used to analyze and forecast stock price, providing valuable insight for investors. Time series analysis. This analysis is a very powerful tool for understanding and modeling various types of time-dependent data, from climate data to transportation pattern. So thank you for attending this lecture, and see you next for the next lecture. Thank you and bye-bye.